With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question says a cylinder rests on a horizontal rotating disc as shown in the figure. Find at what angular velocity omega the cylinder falls off the disc. If the distance between the axis of the disc and cylinder is r, the coefficient of friction, that is mu, greater than d by h, where d is the diameter of the cylinder and and h is its height. Okay, so basically we have to find the angular velocity omega when the cylinder falls off the disc. Okay, so first of all, here we will be having two conditions. Okay, so let's discuss about those conditions. First of all, let us assume that the force that keeps the cylinder at rest is the frictional force. Okay, when the disc is rotating, so in that condition, let us assume the force that keeps the cylinder at rest is the frictional force. Okay, that is F. Okay, first condition. And second, there is also a pseudo force. Okay, whenever the disc is rotating, the centripetal force will be in action. Okay, we know whenever a disc rotates, there is a centripetal force that and whose direction is towards the center. So it will act as a pseudo force on the cylinder. We can write it as pseudo force will also be present. And that pseudo force is the centripetal force. Sorry, centrifugal force. Okay, what it is? Centrifugal force. Okay, centrifugal force, we also known as the pseudo force, in case when the disc will rotate, so this force will be acting on the cylinder. Okay, now the value of this centrifugal force will be F equals to m omega square r. Okay, r will be the distance from the axis of rotation to the center of the cylinder, and r omega is the angular velocity with which the disc is rotating. Okay, now the first condition that comes up here, we will talk about the first one. The cylinder falls off either by slipping or by tilting. Okay, first condition is that the cylinder falls either by slipping or tilting. Okay, it means that either the cylinder can slip, okay, or we can say the cylinder can tilt. Okay, it means it will tilt out of the disc. Okay, in that case, the centrifugal force will be equal to the frictional force that is acting on the cylinder. Okay, so we can write it as centrifugal force m omega 1 square. Let us say the angular velocity when the cylinder falls, of the minimum angular velocity required in order to such that the cylinder slips from the surface of the disc is omega 1. Okay, that condition we are talking about. Okay, so let us say omega 1 square into r equals to mu gm. Okay, so it will be equal to, from here we get omega 1 equals to root mu g upon r. Okay, from here we get omega 1 will be equal to mu g upon r. Now the second condition is the F force, the centrifugal force, tries to rotate the cylinder, but the weight opposes it. Okay, what we are saying here, the centrifugal force tries to rotate the cylinder, but the weight opposes it. Okay, now in this situation, let us say the angular velocity of the disk is omega 2. Okay, now in this situation we are taking the angular velocity omega 2. Okay, so we can, in this situation we can write F, so F into h by 2 will be equal to omega into d by 2. Okay, now value of F, m omega 2 square r into, so half 2 and 2 will cancel out, so we can write it as h, and omega w will be mg into d. So by solving we get omega 2 equals to root d upon h r. Okay, this is the minimum frequency up to this frequency. Okay, up to this frequency. If the frequency exceeds this, then the block of the cylinder will rotate. Okay, the cylinder will rotate. But if it is less than this or equal to this, if the angular velocity of the disk is equal to omega 2 or less than omega 2, in that case the cylinder will not rotate. But if it exceeds omega 2, then it will rotate. Okay, thank you. I hope it's clear to you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.